Routers and packets. Routers transmit data between different networks. Routing is the process of finding a path from sender to receiver. A home router connects local devices to a cable modem, which provides the internet connection. A cable modem, or DSL modem, connects to an internet service provider such as Fios, Comcast, Optimum, etc. An enterprise-level router will connect an ISP to the core internet backbone routers. Routers can either use Ethernet or Wi-Fi to connect to devices. Even if some computers on the internet fail, the system will not. The internet backbone, consisting of many routers, provides multiple pathways for information and data to travel. But major disasters to critical systems can cause major interruptions or slowdowns. Although the internet core is reliable, individual devices that are connected may experience failures of connection because they only connect to a single point. An example of this is when the power goes down in your neighborhood. Your home devices may not have an internet connection because your local ISP lost electricity. However, the internet is still running and working at a global level. The Internet's ability to continue to operate without interruption when one or more of its components fail is called fault-tolerant. There are many layers involved in routing and transmitting data in order to maintain operations, such as reliable protocols that notify the sender whether the data being sent is successful, and multiple pathways between parts of the system that allow for rerouting when one pathway fails. The diagram shown below is a model of the Internet. Notice that there are multiple paths that data can take to travel between any 2 points, which creates the fault-tolerant design. For example, if points B and L are computers and they are trying to communicate, there are multiple paths to get from B to L. A few of the possible paths are listed to the right. We could go to E, then G, then K, then L, or we could go to A, F, G, K, and then L. The Internet's design to have multiple pathways for data is redundant. Redundancy is the inclusion of extra components that can be used to protect against the failure of a system if some of the components fail. Physical redundancy is when there are extra devices and pathways between them for sending data. Examples of this are backups made to hard drives, saving copies of a document in multiple locations, such as flash drives, etc. Even redundant power systems exist. They allow for other power sources to kick in and take over when the main power source fails. As a result, towns and cities don't lose power for an extensive amount of time. Let's return to our example with computers B and L. If the line between B and E is broken, then the data can still reach L because of the redundancy with the paths. However, B would need to travel through A or C before getting to L. How many internet lines would need to be cut to isolate B? Discuss. We would have to cut 3 internet lines to completely isolate B. The line from B to A, from B to E, and from B to C.